everyone, welcome to lecture 3. In this lecture, I'll be discussing about the memory and its types and also about peripheral devices. Let me give you a brief idea of what we will be discussing in the lecture. So, begin. Uh, the basic components of a computer, again, let us revisit it. Processor, which is considered the heart of the system, without which we cannot do it. Main memory. There are various classification of memory you will see. I'll be discussing briefly in this lecture, but there is a very broad details that we have under types of memory. So if we consider main memory is used for storing instructions and data. Well, it is mostly costly, but less costlier than other kinds of memory, like cache memory or registers, like others. But it is still costly. Uh, it has limited size. It is high speed. Mm, the size is limited, but not limited compared to cache memory again. So when we say memory comes as a hierarchy. So at the lowest level, we have certain kinds of memory. Then the next level, then the next level, and then the next level. As we move on from the lowest level to highest level, you will see that the lowest level memories are the fastest, but they are the smallest. The next level is little bigger than those, the lower level, but they are less faster. So the speed decreases as we move from lower level memories to higher level. So we'll discuss all these things, details later, but very briefly, main memory, you should know that main memory is used for storing instructions and data. Let us move to secondary memory. Secondary memory is basically the memory uh, which is stored in the disk. Okay, it's non-volatile storage. The cost is much less compared to main memory and other memory, cache memory and registers and so on. But it has got higher speed. But the compromise is here. These are much more slower compared to all those memories. Okay, as we move from lower to higher, the speed decreases, but the capacity increases. This is the trade-off we have. But we cannot have very high-speed memory at this end. We'll tell you why. And then we have input-output devices. These are required for transferring data between processor memory and, of course, the outside world. And when we say input-output devices, there are various different variety of devices that comes these days. And the way how do you differentiate between these devices? It widely varies in types, different types, and also in speed. You pay more cost, you'll get higher speed. So this is how the trade-off is. Let us move on to the types of memory devices. So the lowest level of memory devices that we have is registers. Okay. Uh, when we will discuss about, I don't think so I'll be discussing in detail in this lecture, but there are various registers that are used when you read computer architecture, which is called program counter, which is called memory address register, which is called memory data register. So these are registers. What it stores? It stores some bits of data. These are limited in you cannot have huge set of register in your computer. You have limited set of registers, and they are very fast. And where they are residing, they are residing inside the processor. Now think of one thing which I already told you, that we bring data and instruction from memory to processor, and then we process it. What if we have some data in the processor? So you can directly access it quickly. Bringing it from memory to processor, it will take time. But if it is inside the processor, it will be much faster, right? You can bring it. That is why these registers are there inside the processor. But we cannot have these registers in large numbers. So we have limited number of registers inside the processor. These are registers, okay? Uh, and they have limited capacity, as I told you. Uh, Generally, they are 32-bit or 64-bit, and they are like, let's say, 30 or 14 numbers. It depends on, again, various architecture to architecture. Then comes another memory, which I will be discussing in the next lecture. But here, I'm telling you main memory, but in between main memory and processor, we have another set of memory called cache memory. I'll tell you why we need that. But let us discuss about main memory. Main memory are relatively faster and of larger capacity. These days it comes in the capacity of 24 gigabytes as well. Okay, so we have a huge main memory, and all the instructions are and data are stored here in main. But we really cannot store everything in main memory. Okay, so what needs to be done? We need more memory. More memory is desirable all the time, but as I told you, we cannot have larger registers. So high speed memory we have limited. Then we have main memory, which is less speed than registers, but still it is higher speed. So we bring the data and instruction into main memory for execution, but we cannot bring everything there. So we need another memory where we can store everything, which is secondary memory, which is relatively slow. And then, but it has got a very large capacity of 1000 gigabytes or even more. Okay. They are non-volatile in nature. So all main memory registers, all are volatile in nature. What do we mean by that? So when the power is switched off, all the information stored here is lost. Okay. But secondary memory is different. They are non-volatile. Data or instruction which are stored here is permanently stored. You can delete it and you can rewrite it, but used for permanent storage of instruction and data, basically. Okay, so I'll discuss in more detail in the class, but this is how it goes. We have high-speed memories which are smaller in numbers. We move on, the speed decreases, but the size increases. Okay, and then register and main memory, as we cannot have huge uh, large registers, large number, we cannot have large number of registers. That is why the concept of cache memory comes in picture. Let us discuss about that as well. What is cache memory? Cache memory sits in between your processor and main memory. Main memory is large, but again, it is not very fast. Why do we need faster memory? With advancement, what has happened is the speed of processor is constantly increasing. Why? These days, in the same area where we used to keep, let's say, 20 transistors, now we can keep 20,000 transistors. I'm just giving a broad example. I mean, this is how it has increased. Okay. Every 18 months, as far as Moore's law is concerned, we already discussed in the first lecture, number of transistors that can be put up in a chip increases every 18 months. Okay, doubles every 18 months. So in that way, the speed of the processor is constantly increasing. But what if the speed of the processor is increasing if you are not able to provide uh, information and feed the processor with information and data that it will process? For that, we also need faster memories, but we do not have it, right? Main memory has limited uh, speed. That is why we have another memory in place called cache memory. That sits between processor and main memory, but it is much smaller in size compared to your main memory. We bring frequent processed instruction and data from main memory to cache memory. And in turn from cache memory, it goes to your processor. Now, always we have been saying that processor is connected to memory. When we say processor is connected to memory, it is connected to cache memory and then to main memory. So data from main memory is brought to cache memory, and from cache memory it is brought to processor. Now why having another set of memory, bringing data from main memory to cache memory, again from cache memory to processor, wouldn't be more cumbersome? No. Why? Once we bring certain set of data or instruction from main memory to your cache memory, it is stored there for some time. And due to the inherent property of computer execution that frequently used instruction on data will be used again in future, that helps that we do not have to go to main memory for accessing the data because it is already stored in cache memory. So this is where the advantage of cache memory comes into picture. So this is very briefly I have told you about cache memory. You will see that cache memory itself huge cell. You have cache coherence problem, and there are many things. There are different levels of cache we have, but ultimately this is how it works. That is why we require this. And again, I have not discussed in this lecture, but I'll be discussing in the main lecture. Memory is broadly divided into many types. One is static RAM, basically RAM, random access memory. Static RAM and dynamic RAM. Cache memory comes in the category of static RAM. Dynamic memory comes in, main memory comes into the category of dynamic RAM. We'll see the differences and why we need those things in later lecture. In this lecture, maybe the in-class lecture, okay? So this is what I already discussed with you, that memory classification. We have various classification. We have volatile and non-volatile memory. What is volatile memory? The data or information are lost when the power is off or it is switched off, right? So main memory, cache memory, registers are all broad category of volatile memory. And what is non-volatile memory? Your disk. You store certain instruction or certain data, it is still stored there. So those are nothing but non-volatile memory. Fine. Then we have various other categories, which is called random access, then serial access or direct access. So by random access, what we mean is access time does not depend on the location being accessed. It's any location, first location or the last location. It is simply random. Okay, everything will take same time. But what is the example? The examples are semiconductor. Today's memory, the main memory that you have in your computer is basically random access. Flash memory, SSD, basically a random access. Then we have serial. Location must be accessed sequentially one after the other. So magnetic tape is one of the examples. We'll see in detail how it works and all, but this is serial, one by one by one. You cannot go to any random location like what we can do in random access memory. In serial access, like in magnetic tape, one by one by one, from 1, 2, and then it moves on. And direct access is basically part of the access time is random and part is direct. So the example is magnetic disk, which we usually used to use earlier days. Okay, this is various categories or classification of memory. Broadly, I told you we'll be discussing about read-only memory, random access memory. Read-only memory are basically used for storing read-only. So we permanently store some information here. The information is basically hard-coded or burned by the manufacturer. So before we use. But these days, the general concept was we cannot modify the content. Okay. But later we saw that the use changes. The requirement changes and we need various other kinds, right? Programmable read-only memory. call it prod. Then we have erasable programmable read-only memory. Then we have electrically erasable programmable read-only memory. We'll see all these different kinds of varieties of ROM in detail in the in-class lecture. Let's move on with RAM. I already discussed with you. The broad categories of random access memory comes along with static and dynamic RAM. By static RAM, we say that data stored in tiny cells called flip-flops. You will see in course of time what is a flip-flop. Flip-flop is a circuit which is a sequential circuit which is built using gates, and gates are ultimately built using transistors. So everything boils down to transistor again. Dynamic storage, it is basically here the data is stored as charge on tiny capacitors. So data here is not stored in circuits called flip-flop, but in capacitors, which is slower. Okay, but static is much more faster. This is how these are the categories. Now goes to secondary storage devices. You have hard disk, we have CD-ROM, DVDs, solid state device, SSDs these days have come, which has replaced the hard disk with SSD. Then we have magnetic tape, etc. We'll discuss all these in detail in the lecture. Now comes to input output devices. There are various, you already know the various kinds of input output devices like displays, your monitors, your printers, scanners, tablets, which could be connected and you can do any operation. The data is coming from here, which is input going input here, input to the computer. We have mouse, we have keyboards, and many more. It has got very. We'll be discussing about all these devices as well in this lecture. So let's wait for the final class and hope you like this.